We often hear that the NNI brought people together across disciplines in a way that was novel at the time, and it's become accepted. It's become the way we do science, is really reaching across boundaries. From your perspective, can you comment on that interdisciplinarity?
I think nanotechnology has been one of the greatest gifts to science, not just because it was a grand opportunity to discover new materials and new capabilities in science, but it changed the way we do science. If you do nanotechnology research properly, you realize you can't do it alone. You realize that you need a group of different types of individuals to do it properly. And so I think one of the really nice things that we've seen happen over the last couple of decades is this idea that we should have fiefdoms, where you build walls around what you do and try to be the best at that and not allow anybody else in, to really open up and realize that you can get a lot more done by working together. It's a much more efficient way of doing science, but it's also a better way of doing science. You can get a higher quality answer by merging the capabilities and expertise from people both within your discipline and also outside of your discipline.
I think that, and I give credit really to one of the founders of the initiative, Mike Rocco, who was a really very visionary and broad thinker. So by design, the people who started the program saw nanotechnology as multidisciplinary and therefore cutting across all kinds of boundaries. And whether that meant divisions within funding agencies or departments at universities or offices within professional societies and scientific organizations, nanotechnology didn't just fit simply and neatly into any one area. And so it forced the bureaucracies and the cultures of those organizations to change. And I think that in some ways is one of the biggest impacts of nanotechnology to this day. And not only do faculty continue to do multidisciplinary team-based research, but the students who were there, learning and growing up in that environment don't know another way, in a sense. And so they've graduated now and they think that's the only way to do things, in a sense.
I think that nanotechnology itself, if there's one thing that it did that is absolutely unique, it is to create this opportunity for intersection of disciplines. And never before, I think, had we seen mathematics meet biology and biology meet physics, physics meeting surface science, and of course, being a chemist, I have to say everybody meeting the chemist.
Nanoscience really bridges across so many different areas, be that chemistry, be it physics, be it electrical engineering. When I walk around the building here, I don't want to say it's impossible to tell what the individual's background is, their training, because we're all working on ultimately the same sort of things, working on exploring these different nanostructures, nano devices. And it takes a wide variety of backgrounds to do that. There's a lot of, you see this more generally in the materials science field as a whole. It really is a nexus of different disciplines that takes advantage of the skill sets of each one of these different disciplines and brings it together. Now, one of the newest groups that you see really getting pulled into the nanoscience community very strongly is the data analytics. As we're developing new tools for studying nanostructures and nanomaterials, we're now getting just such a tremendous amount of data that we're relying on experts in data analytics and data handling and data processing to really tell us what is there to discover.
The way that nanoscience and nanotechnology had developed was that people from different fields, chemistry, physics, biology, engineering, medicine, environmental health and safety, and other areas, all got together and we taught each other our approaches and our problems, and we adopted those as a community. And so we realized that it's incumbent upon us to take on those problems.
Nanotechnology research and development as a whole has been very synergistic. People with different expertise and perspectives learning from each other, and out of this learning comes some collaborations which have been really strong. And I'd say it's truly an area of convergence. And I have to say that in the very beginning, it was difficult. People are used to their disciplinary silos, they're used to their terminology, they're used to the concepts. And so there's a whole culture that grows up in an academic discipline. And listening to some of the work and ideas and directions from other disciplines, it is at first challenging because they use different language, they use different terminology. But this interdisciplinary science, I think, it's really been catalytic for science as a whole, and then advancing nanotechnology far faster than I or most people imagined would happen.
I think one of the things that the NNI has really done is made a community of people focused on nanotechnology, and we need people of very different backgrounds to come together to really make this work. So we need material scientists, physicists, chemists, theorists, and electrical engineers like myself to come together and really make it work. And that was something that was a lot less common in the early days of nanotech. My philosophy is you need to look at your team, figure out where you need to complement your team, and try to hire the best people. And I think that's something that NNI also has been very effective at doing, is mixing people from different disciplines to really focus on a goal and accomplish it.
There are so many people that I've met at the NNI stakeholder workshops, and I go back to those early meetings. And keep in mind, here I am as at the time, a biologist, and meeting people in the material science world, the geosciences world, environmental engineering. It was really interdisciplinary from the very beginning, and everyone was together working on, nano was this huge challenge, and it took a little bit from everybody to make the advancements that we have, not just in the environmental health and safety areas, but in the application areas. A lot of us never had worked with electron microscopes when we first started this journey, but there were folks in disciplines who had been working with those things for decades. And so the ability to talk with those folks and cross-pollinate ideas. So again, speaking from the biologist, environmental toxicologist side, it was, okay, how can I measure this material? How can I dose it appropriately? And the answers to those questions really came from other disciplines, and it wasn't unique in my case. You pick a problem in nano, and it had some interdisciplinary component to it.
What I think is also exciting, in addition to conversations among the sciences, we're beginning to see conversations between scientists and the humanities on ethical challenges, and also we're seeing a growing focus on sustainability and environmentally benign systems. There is a Center for Environmentally Benign Manufacturing that is centered at the University of Arizona, Tucson. It was started in 1996, initially to develop high-performance sustainable processes for semiconductor processing. But in the mid-2000s, right when the NNI was getting going, the conversation switched. And for the first time, we saw the electronics community embracing folks from the biotechnology community and asking them hard questions like, if we want to include new materials in our manufacturing, will this be sustainable? What are the potential hazards?
In the very early days of nanotechnology, you had to have your own facilities and tools to be able to do anything. And so the progress was relatively slow. But then one of the tremendous investments we made was in national facilities to make this technology available to everybody. But it wasn't just the availability of all these tools and the fabrication and the characterization. It was to bring everyone together. And the real advances were the people collaborating, talking to each other, doing similar fabrications, getting new ideas. So this entire infrastructure really evolved a collaborative spirit through nanoscience. Today, if you look at some of the teams of people doing various research projects, they're spread all over the country, and they've been brought together by these collaborative networks.
Thank you for joining us today for this special 15-year anniversary edition of Stories from the NNI. If you would like to learn more about nanotechnology, please visit nano.gov or email us at info@nnco.nano.gov. And check back here for more stories.